Okay, so I wanted to do a short video now that I finally have a load tester and I can test the buck converter the way that I wanted to. And sorry for the low quality image here, but I've tried a bunch of different ways to get this to pick up on the camera and there's just too much glare otherwise. So let me set this up. I've got 9 volts coming in on the input. Buck converter is set to 5 volts, or as you see here, 5.06. We're going to run it through various tests, see what it can do. Now, because the track widths are so small on this, according to every chart that I've read, says that it should only be able to handle about a 1 amp max. And like I said, I originally designed it to be able to do 3 amps. But as I already said in the previous video, they're going to have to be sent off and have the traces adjusted. Schematic's already been done on that, and I'll be sending it off probably this week. But we'll go ahead and do the tests. So what I'm going to do is take a few measurements, one at almost a half amp. Well, I overshot that a whole lot, didn't I? So bring this down. There we go. Good enough for me. So 0.47 or just under a half amp. Notice the voltage. It's still holding steady at 5.06. So I'll record those measurements and then we'll move up to the next one. By the way, my power supply set at 9 volts is pulling 0.3 amps right now. So a pretty decent amount under. So we'll use all this to determine efficiency here in a minute. Now we'll bump up to the next one, about 3/4 of an amp. Good enough. So now the power supply feeding the buck converter is showing still 9 volts solid and 0.47 on the current. And then if we look on the load tester here, still holding at 5.06, current of 0.74. Well, 72, 74, bouncing around, but holding pretty steady. Now we'll crank it up to 1 amp. Alright, so we're at 1.02. We'll just call that 1. Still holding at 5.06 volts. So voltage hasn't sagged, so that's a good thing. I'm pulling 0.65, 0.64, 0.65 off the input power supply in terms of current. Now, I'm pretty sure if everything holds steady, as I move up, you're going to see the voltage start to sag and drop off. Yep, there we go. So we get to 1.2 amps and the voltage sags a little bit. So that's about what it calculated out to be. So once I get those traces done, it should be able to handle the full 3 amps, no problem. And then we can start moving on building cooler things. So if I switch over to and forgive me about this too, for whatever reason OBS is not capturing just the window. I got to do the whole screen, so you're going to get this whole inception effect going on. Give me a second. There we go. Okay, so we're looking at if I can get my mouse to work here. So we've got on the input power supply, solid steady 9 volts. This is the current that it was drawing at each one of those tests. So to calculate the wattage or the power, multiply the current times the voltage, and then you get your power. So on the buck inverter, the voltage out is set at 5.06 volts. And then we did 0.47, 0.74, and 1 amp. Do those conversions and to get your power based on that. And then the differences between, I forget what the formula is on that. So, yeah, the buck wattage and the power supply wattage, this one, will give you your efficiency, which honestly for this little guy, that's pretty good. When I was in college and we were doing power supplies, we were lucky to get about 60% efficiency. If you could get it up to 72, 73, you were firing on all cylinders and everything was great. But 87% efficiency, I will take that. So anyway, I just wanted to drop this video. We'll do it again when I get the new boards in, just to verify that they can do the full 3 amps, and then we'll start working on microcontrollers. So we'll catch you guys in the next one.